Okay, for today's warm-up, I'd like you to do these problems and then keep doing them over and over again until I am ready to go. So for practice, build those repetitions. So here we go. Those first problems. Remember, 4 squared is 4 times 4. So 4 times 4 gives you 16. 7 squared, 7 times 7 gives you 49. Remember, never multiply a base times a power. This is always 4 times itself twice. Never multiply 7 times 2. Never multiply a base times a power. This is 7 times 7, 49. Those next problems are square rooting, which is the opposite of taking it to the second power or squaring. Square rooting says what number times itself gives you 16. These are perfect squares, which means there's always a number times exactly itself to give you 16. So that number would have to be 4, because 4 times 4 gives you 16. So the square root of 16 is 4. The square root of 36 is 6. The square root of 25 is 5. Again, remember, 5 times 5 gives you 25. That's why the square root of 25 is 5. 6 times 6 gives you 36. Square root of 9 is 3. Square root of 4 is 2. I expect you to memorize these perfect roots: 4, 9, 16, 36, 25. These are the perfect roots we expect you to memorize, and even the square root of 49. All right, keep going. When you take something that's square rooted to the second power, remember you're multiplying square root of 3 times another square root of 3. You multiply the numbers and you get square root of 9, and then of course that is the whole number 3. Notice when I square root this, that square root symbol goes away. So now you have a nice neat whole number. Notice the square root symbol goes away when you square root. Don't leave that square root symbol over it. Next one, root 5 times root 5 gives me the square root of 5 times 5, the square root of 25, which is the whole number 5. Again, remember, when you square root 25, that square root symbol goes away, and now you have the whole number 5. All right, Pythagorean theorem problems. For this first one, I'm giving you the 2 legs. And how do I know these are the legs? Because these values are on either side of this key right angle right here. So 5 and 3 need to go together in the Pythagorean theorem formula. You could mix the order of these 2 up, but you cannot place this C value over here or one of the leg values over here. I'm going to flip this around so you have the variable you're solving for on the left, which some of you are more used to. 3 squared is 9, 5 squared is 25. When I add those up, I get 34. Right here, I need you to show the inverse operation. The opposite of squaring is square rooting. When you do that, these cancel away and just leave you the whole number C, or the whole value C. And then the square root of 34 is not a perfect root at this point. I'm going to leave that alone. Next problem. One of the legs is one of the missing unknowns, so be careful. Do not put 10 and root 2 together. These are not the legs. The legs are always on either side of this right angle. So I'm going to put this root 2, and then this unknown, I'm going to call it b. So root 2 squared plus b squared equals 10 squared. Remember, when you square root 2, you get just the whole number 2. But when you square 10, you get 10 times 10, 100. So make sure you know the difference. Here I need to do one inverse operation. That's going to give me b squared equals 98. This can be broken down, but at this point we're going to leave it alone. The roots cancel away with that second power and just leaves me b. And then I'm just going to leave it root 98. So when you're doing, keep going on these problems. Keep going. If you want to mix up some of your own numbers, feel free. But I would practice these Pythagorean theorem problems over and over again until I'm ready. Good luck.